Hey parents and guardians, my name is Patrick Thrasher and I am the physics teacher here at San Mateo. And for this open house video, while I don't want to take up too much of your time, I hope to go over some of the basics as well as showcase a little bit of work that your child may have done over the course of last semester, what we're doing this semester, and also a little bit about where we're going, okay? Now, this is our physics class, our regular high school level physics. Now, what are the things that we're working on this class? Obviously, we're learning science. But one of the things I really like about physics is that we've wrapped the semesters around some fundamental questions. Like, we don't just learn about all right, gang, this unit is about motion. The next unit is about energy. Oh my gosh, that's what I grew up with, and it was incredibly boring. So instead, what we're looking at are fundamental questions, like this first one. This is actually our first unit, what we did back in the fall. Why don't school buses require seatbelts? Now that's a big question, and there's a lot of physics reasons, but also some non-physics reasons. So we spend time learning the science, and also learning, frankly, some of the non-science that helps answer this question. This unit is where we learn about things like speed and acceleration. And maybe you could start thinking about, imagine how fast a bus is able to accelerate. Think of how quickly a bus might slow to a stop. Think of the momentum of a bus. Think about the other things in the bus that might help keep a child safe. And some non-science things is let's imagine the typical bus route. Are buses normally traveling at high speeds? Are people trained who are driving the bus? So there's a lot of stuff that goes into answering this kind of question. A lot of it being physics, and also some of it not quite being physics. And that's true for a lot of these things. Another key question, certainly it sounds a little more sciencey, how are black holes and electrons similar? We spend about 6 weeks learning a lot of background science so that students can see the connection, the physics connection between these two seemingly very different things. Okay, we also learn about bananas and dinosaurs and Einstein. They're all related with the idea of nuclear decay and nuclear processes. So that's kind of the main heart of that topic. And what we're doing right now, one of my favorite topics, focusing on waves. How do you take, send, and view an Instagram story? So we use these big questions as the focus of what we're learning and why we're learning it, which helps put everything into context, in my opinion. Now, in terms of class grades, some more logistical ideas, this class is based on objectives. So you might know from your son or daughter, we often have these quick little quizzes. They're not really a typical quiz. Usually we have one about once a week or so, and they're usually just 1 or 2 questions. It's assessing something like, do you know how to use conservation of energy? So I just have a quick question, maybe 2, asking about conservation of energy. Then the next week, as we're learning about, say, sound waves, there'll be a quiz question asking about sound waves. So I've really removed big tests, and instead we just do these little checks. I call them objective quizzes. And if they can prove that they know that physics as we're learning it, perfect. If they can't prove their knowledge just yet, well, on the bright side, students can retry any objective quiz. They can also retry and complete past homework assignments. So there's not much holding kids back, even at this stage, from getting, say, an A or a B in the class. They can retry quizzes almost as many times as they want. They can still complete homeworks. All right, so them having a C right now, that is not a limitation on what grades they might be able to get by the end of the semester. All right, and then based on answering these big questions, my third bullet point right here, I hope that kids are able to leave class with a better understanding of how our universe works. Why a lot of school buses or a lot of, say, states or counties don't require seatbelts, because buses have other safety mechanisms built in. The motion that they experience is different from, say, a car on the highway. They're able to apply physics to answer some questions that describe how our world works, and certainly how our world is utilizing these physics concepts. All right? Now, for this class in general, well, it's obviously a physical science class, and so the state of California and our school district requires 1 year of physical science. So nice, that's taken care of with this course. It is also a D requirement from the UC and CSU A through G list of requirements. Now, UC recommends 3 years, and it requires 2 years. So this is counting as 1 year of their 2 to 3 recommendations / requirements, all right? And then also this class as a science class is going to prepare your child for future science classes, whether it's chemistry, San Mateo offers some great biotech classes, and of course the various APs we offer. Now, I'm not saying that regular physics is required for AP physics, but this class is just, in terms of practicing science and doing science, is good for preparation for any additional science class that they might want to take here at San Mateo. All right? And if your son or daughter, your child is enrolled in this class right now, certainly you can find more information in Canvas. All right? Now, just kind of to wrap up, I want to point out some highlights from these big questions. Now, I apologize, I can't show examples from every student in this video. We'd be here for an hour and a half. Your son or daughter, your child, should have links to these things. They should be able to show you what they created. But I always do these capstones at the end. Like, all right, we focused on this big question, we learned some physics, so now show me what you know. For this first question, I said, let's pretend San Mateo introduced a bill requiring seatbelts on buses. And so they had to both apply their own physics knowledge, maybe like, well, buses don't feel that much acceleration. Or with the soft seats in school buses, their safety is already kind of taken into account using the impulse equation, a big idea in safety for physics. Okay? Or they did some research, like, man, the cost of installing seatbelts is really high or really low. And then they had to decide with their group, do they support this measure or do they not support it? And I said, make kind of a fake Google Slides presentation as if you were to present this to, say, the county board. So they get to be a little bit creative, they get to be a little bit argumentative, and they present what they know. And here are some sample title slides. When we were looking at black holes and electrons, I told them, pretend like you're making like either a dating website or just a social media website, and you're maybe having a fake conversation between a black hole and an electron. You're setting up like a Facebook page with likes and dislikes. Prove to me, show me that you know a little bit of science by being creative and putting it in the context of something that I think all of our kids are familiar with and maybe they're a little more excited with than just being in a Zoom class all day. So these are some of the great things, great examples that kids came up with for this unit. And then one more example for this one, answering this question, I said, make a set of Instagram stories. And, Instagram stories, you're supposed to just kind of skim through them. So I wasn't expecting some, massive paragraph of text. But if you were to condense some physics that we learned in a 10-second, say, glance at an Instagram story, what might you say? And again, these are some great examples of kids incorporating some of the info, some of the physics that they learned in applications that they're more familiar with. All right, so I like doing these capstones where kids can also be a bit creative and apply what they learned. All right, our current highlight, what we're working on right now is this question. This question focuses on sound waves, light waves, a little bit about data transmission, and things like flash, like how your phone stores data. And we'll again have a capstone with this, but we kind of just started this unit. We'll be doing this for another 3 to 4 weeks. All right, and then looking forward, if we're at a distance especially, we'll be spending our time looking at some astronomy topics in physics, understanding our place in the universe, how we came from stars, how our universe evolves. That's where we're going forward after this unit about sending Instagram stories. Okay? Now, for learning at a distance, I'm watching the clock. I focus a lot on ClassKick, so your kids should be familiar with that. They should be able to show you work from that, as well as Google Slides. I use breakout rooms a lot when we're practicing these things, so they have the opportunity to talk with their peers. And what I like about Canvas is I can give audio feedback for their quizzes. So kids should always know what they're losing points on. And you could therefore ask them, like, hey, why did you get a 3 on this quiz? You could listen to my comments. All right, oh my gosh, this time was way too short to give a total overview. Feel free to email me either through this address or through Canvas, okay? I appreciate your time in viewing this video. Thank you very much. All right, again, feel free to message me any concerns. Take care. Thank you.